Okay, I know the talk after the lunch is always difficult, but I hope it will become interesting for you. We will talk a little bit about introduction, what is the root cause of SQL injection, how can we detect an attack, what's the anonymity of an attack, and countermeasures and how to implement it. Nowadays, SQL injection is one of the most common problems in the database world, and all the web applications are persistently under attack from the internet. And if the attack was successful or is successful, the data is lost and sometimes posted on pastebin or just stolen. And nowadays, the majority of the attacker, they are using tools like Pangolin, Havi, and all these kind of stuff. And in the presentation from last year, I found also a few numbers, so I just copied them. This is statistics from Imperva. They monitored 30 web applications, and they had around 71 SQL injection attempts per second, and up to 800 to 1300 injection attempts at the peak time. And they also realized that the majority of the attackers are using tools, because people are lazy. Why should you do it manually if there's a tool where you just click and point? So people are using tools. And last year there was a talk about protecting databases with trees. Christian Bockermann, he comes from the university, so this talk was quite academic. It's interesting. And comparing to my approach, is this complex? So I'm using a really simple way, and you can implement it in a few hours in your system. The big advantage of the approach you will see is it's not necessary to modify your application, and it's not complex. It's easy to enable and also easy to disable. What is the root cause of SQL injection? We have the problem, we have so many vulnerable systems, and the solution is quite easy. We only have to fix all the vulnerable web applications in our company or organization, and then we don't have any problem anymore. But do you think this is realistic? So if you are working in a big organization, you know that's not really realistic. There's no secure code. In the majority of all cases, you don't have time to perform a pen test, or time in a company is similar to budget. You're using applications longer than expected, sometimes 10 years and longer. And in many cases, there are no patches available, there's no patch strategy, so it's difficult to fix this problem. And if we cannot fix the SQL injection problem, we have to search for another way. And before we start finding the solution or an approach, we should have a look how is a SQL injection attack performed. And I'm quite sure some of you here in the room already did this several times. A typical attacker is normally using a tool like NetSparker, Matrixay, SQL Map, or he's using Google to find a SQL injection vulnerability. The next step is to select the tables the attacker wants to download, and then you download the data with a tool. Let's have a look at find a SQL injection vulnerability. This is really, really easy if you just want to find one or multiple vulnerabilities. So here I was looking for OCI execute and this error message, and then I got from Google the result. Here, for example, Stone Peak Ceramics, they have a URL, and this returns quoted string not properly terminated. I always try to use stuff from the country where I give the presentation. So I was just looking for OCI execute. This is an error message created by PHP. And I said, okay, search only in Switzerland. And then I found one page, SwissGeo. I'm not sure what they exactly do, some geo stuff. And you can see SQL command not properly terminated. So I started a page by clicking on the Google link, and you can see here OCI execute SQL command not properly ended. The next thing an attacker normally does, he looks at the URL. So here we have a number, and here we have something random member, and you can see some weird character. So. And I think that this is the point where the Google Spider was creating this error message. So we are replacing this error message, or this strange string, with single quote or 1 equal UTL in RDDR, get host address, and here you can insert your own SQL statement. And with minus minus, we terminate the statement, so everything is running. And now we are getting a different SQL statement, and later in the talk, we will see that this is a typical pattern for SQL injection attack. This means Java is not installed, and the attacker was trying to use a Java function. So this is also an older Oracle database, because in newer databases, Java is not necessary for this attack. So just rewriting this URL would now allow me to download everything from the database. And this was a manual attack, but if you are using a tool, everything is much faster. So using a tool, you can, this is a Chinese tool, you can specify a URL or a web page. In the next step, you can say scan the entire subdomain or scan the current domain. You can specify the scan level, how many threads should be used. And you can specify what are you looking for, and here we are only looking for SQL injection. So to use such a tool, it's not rocket science. You just have to click and you have to know, okay, I want to look for SQL injection. And then you start the tool, and if it finds a vulnerability, these tools are normally offering you the table names. So here you see they found, this tool found a vulnerability. Dept, dummy, emp, sulcrate, and suit are column names. And here you see with the O3, there are 3 columns in the table dept. And by using a right mouse click, you can now download all the information from this schema. Other tools are doing it similarly. This is Havi. This is another Chinese tool. So here you see the tables. You can specify which columns are used. And then if you download them, you can say save, and you get a CSV file with the information. So it's nowadays really easy for the majority of SQL injection vulnerabilities in a web page to download the data and get everything back. And as a rule of thumb, it takes less than 2 minutes before they start downloading data from your website. So as a company or organization, you have to react within 2 minutes. So in a perfect world, the manager on duty, which is responsible for the operating of all the applications and systems in your organization, is getting some notification, an attack is going on, and within 2 minutes he's stopping the service and nobody can do anything with this vulnerability. I heard some laughs. Is it realistic? No. So if you are 2 days, then probably that's more realistic. My experience in several cases, companies never realized that they were hacked and the data is lost. The problem, these 2 minutes coming from the tools, it's too short for human reaction. And even if you have a CM system or a security operation center, 2 minutes, nobody can react that fast. I will not say nobody, probably there are 1 or 2 companies in the world which could react that fast, but it's not realistic for the rest of the world. And another problem, the majority of companies do not have action plans. What happens if we are under attack? Can we shut down or stop the system? What are the side effects? Is someone only complaining? Are other services dependent from this web system, and so on? And if you are a normal manager on duty responsible for 1,000 applications or systems, you would never shut down or stop a system. Because if you stop the wrong system, you probably lose your job. So we don't live in a perfect world, and the problems are the humans, so we need a solution without human beings. The system itself has to detect the hacking attempt, and then the system has to take the right countermeasures. Question is, who could detect an attack? So the typical suspects are web application firewall. But the web application firewall is normally blocking suspicious attacks, and hackers are always interested to bypass these by using special encoding schemes and so on. So a web application firewall can reduce the risk, but if you, there are often ways to bypass the WAF. The web server can act similar to a WAF using, for example, mod security. So this is also limited. The application itself normally does not detect a SQL injection because the vulnerability is in the application itself. So I think the best way to find an attack is the database itself by looking at the error messages. So out of the box, systems like Oracle and SQL Server are able to detect and react on specific error messages. And one of the speakers, Xavier, he also implemented this yesterday or the day before to MySQL using a MySQL proxy. We will later see details. And you only get an error message, for example, quoted string not properly terminated, if the system is vulnerable. So there's no random error message, and it's quite rare that you have false positives. If you have a really poor software and the developers are sending incorrect statements to the database, then it could be possible that you are triggering this error message. How could we implement this? In Oracle, we can use an Oracle database trigger. I will have an example. For SQL Server, I started, but I hadn't time to finish it. And Xavier did it for MySQL using the proxy. How can we detect a SQL injection via error messages? And that's simple because the majority of the attacks, they are starting with an error. So if you have a union, if you extend a query, if you use error messages to retrieve data, you are getting error message. For example, query block has incorrect number of result columns. So in this case, you know someone is trying to play with the union statement. Or here, Oracle, Microsoft SQL Server error message, where you put the vulnerable string in the error message, or the sensitive data. And here is how an attack looks like, including the statements. This was the idea of the developer. Select customer name, customer ID, customer order from customer. And now we have an attacker, and the attacker is appending union, select username, null, password from DBA users. So if you run it, you see in the same output username and passwords. And you can often see these kind of examples in all kind of documentation. But what is missing, that normally there's no direct way from an original statement to the injected statement. In between, you have a lot of different attempts to get a proper SQL statement. So here I have a small web application showing the Oracle M table. And this is done with Oracle Reports. And Oracle Reports has a nice feature. If you append a parameter in the URL, param form is yes. Then a new window pops up in the browser, and you can modify the where condition. So now the developer has order by one to change the sort order, and now we can override this order by one with our own SQL code. In this case, I would start using union select null, username from DBA users. And if I click on submit query, this is concatenated and executed. But the typical the next step is not that I'm getting the result. The next step is I'm getting an error message. Query block has incorrect number of result columns if I inject this one. So the attacker or the tool knows we have to add additional columns. So now you are appending null until this error message disappears. So in most SQL injection attack scenarios, you are appending stuff until you get a well-formed SQL statement. And the chances that you are getting a well-formed SQL statement using a tool is nearly next to null. And then we are getting, if you are successful, the statement is executed properly and we have everything. In the next 2 slides are the typical Oracle error messages. So let's say we have the error 1476, divisor is equal to 0. This is a typical error message from SQL map, so from SQL map. Because this tool is trying blind injection using decode and division is equal to 0. So we know that this is a candidate for SQL map. Or here we have this from the Swiss Geo, SQL command not properly terminated. Sometimes you find missing left, right parentheses if you have a SQL command with a lot of parentheses. And we saw our query block has incorrect number of result columns. Here someone tries to attempt a union select. And if you know the number of parameters, the next step is you have to find out the data types. And then you are running in the next error message. Or this was the error message, class does not exist. So someone was trying to use util-in ADDR, but Java was not installed. And in the normal application, you will never see these kind of error messages. So for SQL Server, I have less data. Typical is unclosed quotation mark before the character string. If someone is using a single quote, or this converting error if someone is using minus minus. And there's also in the documentation, there are pages where you can get more of these error messages. We know now there are a lot of error messages which are more or less unique for SQL injection attacks. And now our system could do something. So in case of SQL Server, using event notification. In case of Oracle, using an error trigger. In case of MySQL, using a proxy. If you are carefully, you just detect this and you send an email. But in the real world, you will lose data. So you're just aware that someone stole your data. You could also send an email to the responsible manager. But what I would recommend is lock the database account. Because if you are a manager on duty, we will see this. What do you prefer? That someone steals your data and it's posted on Pastebin or at the Blick or some other newspaper says this company is hacked, or that the system is not available for an hour or 2. What do you prefer? Who would shut or who would stop the system to avoid an attack? Only a few hands. Who would let the attacker steal the data? One hand? This guy? Why would you let people steal the data or copy the data? But then it's an organization problem. So I agree, a manager should decide this system is so important, we stop it before something is stolen. And you can say, okay, we don't have SQL injection, so this case should never happen, but you never know what will be added in the future. And after locking the account, we have still sessions which are connected to the database, so we have to terminate the session. And we can limit the impact if you are using different accounts. For example, your internal employees are using a different account to connect to the database. So if someone is attacking from the outside, you are only blocking the people from the outside, but your internal employees can still work. So this would be an option. Or we can only block people coming from special IP addresses. And to avoid false positive, everything which is not, every error message which is not created from the web application server is ignored. So if you are using some tool like SQL Management Studio or SQL Plus or Toad, you are not locking the system, only if it's coming from the web application. And the implementation here for Oracle is quite simple. You can download it and play with it. You say after an error occurred in the database, first we are getting the executable which was triggering the error, and then we are reconstructing the SQL statement. In Oracle, a SQL statement can be longer than 2000 bytes. So if it's longer, then we have to cut everything, concatenate everything together. And at the end of the round, you have the SQL text. Here we cut everything together. And then we say if the program which was triggering this error is the Internet Information Server, and if one of these error messages occur, you can now decide, monitor the attack, send an email, log the user, terminate the session, do some other countermeasures. And it's clear this is a simple solution. If you want to implement it in your own environment, you have to spend a little bit more time doing it. For SQL Server, it's also possible, but they have a concept of event notification. They do not have an error trigger, and you can create an event for certain SQL injection errors, and then run a stored procedure code whenever this error occurs. MySQL, so I gave a manager version of this presentation 2 days ago, and Xavier also joined this presentation. And this is his idea. He's using a MySQL proxy. If the web application, so the client is sending a statement, it's no longer connecting directly to the database, it's connecting to the proxy. And the proxy is enhancing the SQL statement. And here he's appending show warnings. And if you have show warnings, you are getting all the error messages from the database. And the result is written to a log file using a UDF function, and then you can react on it. So you can have a trigger looking that something is going on, and then you can also start your countermeasures. And he has a blog post, so there's a URL here. If you have the PDF, you can see it, and you have more details on his blog post. From the countermeasures, we already talked about what could we do. Sending an email and just monitoring the event is, in my opinion, not enough. But this has the smallest footprint. So you are not affecting the availability, but you still see that something is going on. So we are not solving the problem with the fast response. In my opinion, if you are really under attack, it's better to stop, and no data is lost, but it acts as a denial of service because the service is no longer available, and we have potential false positive. We will see this in a few slides. Yesterday night, I got an idea from Mark Heuse. He said, okay, is the database able to strike back? And I said, hey, that's not a bad idea. So if you have a denial of service tool on your system, the database could even get the IP from the attacker and then start a denial of service against this IP address. The question is this legal? It's possible, and you should have a look if the attacker is using a proxy. So if you are using a proxy, then you would only DOS the proxy system. And the big question is what happens after such an incident? What do you prefer? And this is a management decision. No developer, no DBA can decide this. The management must decide what is important. But from my experience, if you lock a system, it's much easier for a manager on duty to re-enable the system. So let's say the system is down, then you can analyze which statement was triggering the attack. Let's say someone entered O single quote Leary. And in this case, you have a vulnerable SQL code because a single quote is triggering an error message, but this does not look like an attack. It could be acceptable to re-enable the system again. So the manager on duty is looking at the SQL statement or someone with a little bit experience in SQL, and then you undo this lockout. Another possibility for false positives is if the developer developed the wrong code. The single quotes are missing. And to be more confident if something is an accidental error or is something triggered by a web application scanner, it's possible to detect if a web application scanner is performing the attack, and you can even say which scanner is used. Let's say we have a URL, some PHP program, and here you specify a name, and then you get something back. If you pass this URL to a web application scanner, the web application scanner probably is trying to insert n1 equal union select 1, password from DBA users where username equals system minus minus. And you can get this SQL statement in the error trigger. So the error trigger sees the entire SQL statement. And I know that if I see this string, Akunetics was used. Why is this the case? Because I have a collection of the typical forensic patterns of the different tools. So here we see these are queries which are injected by Akunetics. So if you find these patterns in your error trigger and the error trigger was fired, then you know Akunetics is used. Here we have another example, another URL, and someone is injecting or single quote NS, single quote equal single quote NS. We're getting a different error message, and here I know it's NetSparker, because NetSparker is kindly enough to use the abbreviation NS, but these are other error messages here. Here for some other tool, metrics say, web inspect, pangolin. So they are always quite different. It's clear this will start sooner or later the next round in web application scanning tool to avoid common patterns. But nevertheless, I'm quite sure you will, similar to antivirus programs, you will always be able to find scanner. Also depending from the sequence what was executed. So when we get an error message, we can run a stored procedure, and the stored procedure has all the error messages embedded, and then we can say, okay, someone is trying to attack us with pangolin. And the chances that this attack will be successful are quite high, so we are shutting down the system. And there are various ways to improve the concept. So this was only the simple way. Just install it and the system is down. If you spend more money and more time, you can also modify your application a little bit. So one possibility, we are using different database connections for the different services. So we have one database connect for iOS, one database connect for Android. If someone is trying a SQL injection via Android, only the Android users are affected. Or we can only block IP addresses. We know this IP address is performing the attack, so we are sending an entry to the firewall, and the firewall is blocking only this, or the web application firewall is blocking only this IP address. Or some customers, I have customers in Germany, they said 99% of our customers are coming from Germany, and if someone is coming from another country in the world, we are just blocking everything outside of Germany. This is useful if you are able to communicate with the application and the web application server. Another possibility is to use different weights to decide what you are doing. Let's say someone is creating a SQL injection error message and he's coming from a Tor network. Suspicious? It's more suspicious than from a normal Swisscom IP address. Someone is coming from the intranet. It's less suspicious than Tor, but you should also have a look. Error comes, for example, from Turkmenistan. There's a typo. This and 99% of your customers are coming from here. This also looks suspicious. We could look for minus minus. If there's a minus minus in the string, it's really uncommon that a normal name contains a minus minus. The single quote is more common. We could also look for a typical string from a web application scanner. The combination of single quotes with the characters is also possible to decide if it's suspicious or not. I saw it quite often, O'Connor, so a O followed by a single quote is less suspicious than an X followed by a single quote. I know from French pages, Palme d'Or, and then they're using the single quote as an accent in French words. So there are a lot of different possibilities to make the prediction if something will become bad starts. So you can add and develop your own metric and saying, okay, if someone is doing Tor and using SQL map, we stop the system or we block this IP address. We have other ways to detect SQL injection without using error messages. And that's a simple but helpful idea. You can use fake data or honey data. Because what is an attacker doing? He's looking for something interesting. And what we could do, we create interesting data. And if this data is interesting, the attacker will download it from the internet. So we are creating a table, and the table contains unused data. This data is not used by your application. And this table contains a column called password or salary or credit card. And you know, if someone is accessing this table, this is not your application. But if your web application server is accessing this specific table, you know that you are hacked. Or some of the DBAs know. If it's coming really from the web application process, you know that you are hacked and someone is accessing data. From my experience, once you have a working SQL injection string, people are looking at columns, at views, all tab columns or information schema columns, and they're looking for interesting stuff. And password or French versions like MDP, mot de passe, are typical starting points. So after you have your SQL injection, you're retrieving data from the all tab columns, then you find a password column, and then you are starting select data from this table. And we can monitor these tables because nobody else is using it. We know if someone is doing it, it's an attack. And Oracle has out of the box a functionality called Virtual Private Database. And with Virtual Private Database, you can implement this functionality for free. So we are creating a table. The table name should be similar to the naming convention of the application. So if your table starts with T underscore, this fake table should also contain a T underscore. Then we are inserting data. This can be unencrypted. And we create a function. And the function is doing our activity, sending an email, logging the account. And at the end, using the package dbms ALS, we are assigning this function to a table. So whenever someone is doing is accessing this table, this function is executed and the payload in this function is executed. A similar approach is to use fake functions. Developers nowadays, all the time, are using obvious function names. So a typical function name for decrypting data is called decrypt, so here. And if you are an attacker and you find a an encrypted password field, then it's normal that you call this function. So you say select decrypt from password from app.app users. But in our case, using this fake function, the decrypt function is not decrypting the code. The fake function is sending an email or locking the account. And also the pen testers, if they do pen tests or internal employees, this can be really interesting to find internal employees. So if a DBA is curious what's inside the database, he's probably smart enough to call this function. As a summary, self-defending databases and this approach looking at error messages is really simple to implement. You don't need additional licenses, and it's also easy to deactivate. The implementation is transparent, so it doesn't matter what kind of application you're using, it works out of the box. The biggest problem, in my opinion, is the decision for the management. Should we stop the system or do we allow data loss? And this approach can also be useful for pen tests. So if you activate such a trigger in a pen test, you can find all the error messages you are creating during the pen test. So in this case, you should not stop the system. You'd only send the information, and the potential string which was triggering the SQL injection is sent to the pen testers, for example. Was a little bit faster than expected. Any questions?